Alright, so in this video, we will be rethinking trigonometry. So if you haven't learned it yet, then don't worry. We're gonna get into it from scratch. And if you have learned it, forget what you've learned, alright? Just forget about all of it because we are rethinking trigonometry. That was smooth, if I do say so myself. Alright, so rethinking trigonometry. Just to let you know, we will only need to know two formulas to start this video out. 2 pi r equals circumference, alright, of a circle. And the other one would be a squared plus b squared equals c squared. Now I could prove the second one pretty easily. The first one a little difficult. But don't worry, we don't have to prove these. So we're just going to say these are true. And I think these are widely accepted as true. Both formulas are kind of used on a daily basis in every field. So, either way, those are the two. And we're going to start with this first one. So, to start with it, I'm going to propose a problem. You have the Earth is the equator of the Earth, so right in the middle. And let's assume constant elevation. Alright, so the same height all around. Same height from the center. By the way, the height from the center would be, you haven't learned this before because you forgot everything, right? So good. Radius. That's what we call it. And multiple radiuses would actually be called radii. Spelled like this. I just had to get into that. And diameter would be that full length. Usually I'd use a d there. But I can get it here. Let's just write d just in case it comes in handy. But it won't really for this problem because we only care about the radius. Alright, so here's what we're going to do. Here is the situation. So we wrapped a string around the Earth, and now we're going to make it 1 foot longer in every direction. So imagine you put up sticks or something, I don't know. Just made it 1 foot longer. Alright, so now it's 1 foot higher in every direction. Cool. Did that make sense? Just 1 foot. And we're assuming everything here is in feet. And this is the Earth, again, if you forgot. Earth. So it's 1 foot longer. Or further out, however you want to think of it. Alright, and so the question is, how much did the circumference change? What was the change in circumference? Now, it's tempting to say, well, you can't solve this without knowing the radius of the Earth. But you'd be a little silly because that actually shows that you haven't truly siphoned in all of this information just from this one formula. In fact, there's still more because you forgot all of trig, so it's going to become a useful formula for you. So we have radius, and yeah, we made it 1 foot longer. So here's how to solve it, and we'll see that things will cancel out, so we don't need to know the radius of the Earth. So how much longer did it get? So to find change, you just subtract two values. You subtract the longer value by the smaller value. So the longer value will be 2 pi times r plus 1, because it's 1 foot longer. Then the inner value, 2 pi times r, the radius of the Earth. Alright, so let's factor this in. 2 pi times r and 2 pi times 1. That's 2 pi r, and anything times 1 is itself, so just 2 pi. And we're subtracting all of this, 2 pi r. Now what simplifies? There's a negative 2 pi r over here, and a positive 2 pi r over here. And so they basically annihilate. They're gone. Bye-bye. And so all we're left with is 2 pi. And it should be noted, I didn't say this, but pi is a shortening of this infinite series of numbers, 3.1415, and that's like the extent. I'll give it to you, but some people memorize it for longer. Some people don't even know after 4. Whatever. at least you know that it's greater than 3, less than 4. I think that's at least an important step. So either way, it's 2 pi. And and all of this is in feet. I should have wrote that. In feet. That should be known. So we made it 1 foot longer. So it'll be 2 pi feet. That's the change. And this is kind of bizarre. Like, we moved it 1 foot in every direction. Shouldn't it be much longer than that? Because I think you're just extending all of this. And yet, it's only 2 pi. I mean, we proved it. It has to be 2 pi. That way, 2 pi is also written as, well, tau, like that. Greek letter. Now, some people prefer tau. I'm just showing it. And tau is just 2 pi. It's another way to write this thing times 2. And that thing times 2 is 6.28. I'm guessing here a bit. 3, and there's probably a 0 here. You can check that later. That's not exactly what I want to get into right now. But there's a result. And so it's only about 6 feet longer, even though it's this whole Earth that we expanded it over. Now, in reality, you have change in elevation, and things would be messed up a little bit. But, pretty bizarre result. Just, yeah, I think it's bizarre at least. So, let's go into this. Let's go into trigonometry. Oh, and by the way, one other misconception. I think there's like a misconception in thought, because we always, I think in this line of thinking, the circumference gets larger at a faster rate than the radius. But that's not the case. Looking at this formula, it gets faster at the same rate. 2 pi, I guess, is the rate, but still, it's a similar rate. Let's go into, so this was the other misconception I want to cover. If you have a cylinder, let's talk about diameters just for this little thing. So we're going to use D. And let's say the height is 3 times D. So 3 times the diameter. If diameter was 2 inches, then height would be 6 inches. Now, most people would assume, wow, that is a tall glass or mug, and the circumference has to be less than that. And I think it looks like that. I mean, if you drank out of this, it would look like it would be smaller. But let's do the calculation. And, by the way, diameter, it's 2 times r. So you can rewrite this as 2 times r, which is d, times pi, and they both get you circumference. So d times pi gets you circumference. All right, just reconverting. I guess that's the word. Either way, so d times pi. So that's 3 times d. What is 3 times d versus pi times d? Because that's the circumference. Well, guess what? It is greater than, because that's 3.14 times d, and this is only 3 times d. That's interesting, that this circumference, I mean, this is a tall glass, and yet it's longer around. So that's just an interesting to think about just about this problem right here. All right, let's move on. Let's actually use this formula for something more than misconception. This takes a second. All right, here we go. All right, are we ready? Yeah. So using this fact, 2 pi r, ooh man, that's sloppy pi, equals circumference. Using this fact, let's draw a circle. That's a little sloppy of a circle as well. Either way, so we have the radius. So here's my question. How many radiuses, I should say radii as I said in the beginning, how many radii does it take to go around the full circle? And this is an arbitrary circle. It could be any circle in the world. You plug in whatever number. So how many radii does it take to go around the circumference? And, I mean, looking at this and then looking at this, I mean, it's easy to imagine that the number of radii changed, but it didn't. Let's just find it. So this formula will tell us that. So let's divide both sides by r, as we can. And you get 2 pi on this side. Those r's go away. And c divided by r. So this tells you how many r's go into the circumference? Well, guess what? 2 pi of them, and 2 pi is 6.28. So we have, let's bend it around. Let's make it red so you can see it easier. So this is our radius. We're going to bend it around. So that's 1, 2, 3, 4. Well, no, that's 3 and a little bit. Yeah. All right, so that's halfway. And by halfway would be half of this, which is just pi. But we're not doing that. We're going completely around. So let's keep going. Bend it around. Something like that. I might be overestimating a bit. Then a little bit. And then you have this small distance right here. This would be that 0.28 thing. Because this is a distance of 1, 2, 3, 4, 5, 6, 0.28, whatever. Alright, so that's a full circle. And it doesn't matter the size of the circle. It still stays true. 1, 2, 3, 4, 5, 6, plus a little bit. Alright, so that's what this formula tells us. And so here's what we're going to do. We're going to make a new angle system. You might be used to degrees and stuff, but I prefer this one. In fact, lots of times you don't even have to write what it's called. And we'll go over the name in a second. Let's just come up with a system. So if it takes 2 pi radii to get around the full circle, 2 pi will be full circle. Alright, so it'll just be completely around. Now, what would halfway be? So 180 degrees, whatever. What would this be? Well, guess what? If 2 pi is a full circle, half circle will be pi half. HC, just half circle. And now a quarter. QC, quarter of a circle. That'd be half of that, because 2 halves is the same as a quarter. And so you get pi over 2. This would be a measurement. Pi over 2. That is our angle. And you can keep on doing this, half that, and you get 1/8 of an angle, which would be pi over 4. Now you could also stop here and break this into thirds, like so. And each of those thirds would be pi over 3, because this whole distance is 3, and you broke it up into 3 sections. So each of these is pi over 3. And then you could also break each of those up into 2, I believe. And you should get pi over 6. Am I thinking of that right? Yeah, I have to be. So then you get pi over 6 over there. And these are the useful angle measures. And then the 2 pi is full circle. Alright, and guess what this is called? Well, it's based off of radius, and so we're going to call it radian. So now we have a system for measuring angles called radians. So if I give you, we're never going to work in degrees again, because this is actually really useful. If I give you this, which would be a quarter of a circle plus 1/8 of a circle, quarter of a circle is pi over 2. And if you notice, that's also a right angle. So right angles are pi over 2. That's pi over 2 radians. Pi over 2 rad. And then this is 1/8, which would be pi over 4. Pi over 4 rad. So this whole distance would be pi over 4 plus pi over 2. And I also like this measurement system because you can easily see the fraction. If I tell you 360 and then 180, 80 being half, I mean, it is half of 360, that's okay. But the problem, I think, is that this doesn't have a half in it. Like, you see the half here. Even though this is a quarter of a circle, you can still think of it as this being, since this whole thing is pi, you can still think of this as half of pi, which ends up being a quarter of a full circle. But this one, not so much. It just divides nicely, and that's the thing. So I'm going to continue this another video. And so this is the first concept to get down. And using this 2 pi r formula, you invent this new thing called radians. Oh, and by the way, one other thing about radians. If this angle right here, because this is one radius up here, this is one radian. That usually said radius, but whatever. Now you see, it's one radian. That's the angle measure. And it's less than 90 degrees and greater than 45 degrees. I'm pretty sure it's like 55 degrees, but there you go. That's radians, and we're going to go into other important concepts in trigonometry next video.